Module 2, Lesson 4, find the percent of a number. The objective is students will use bar diagrams, equivalent ratios, number lines, and ratio tables to find the percent of a number. The pacing says that this is probably going to be a 2-day lesson, so let's quit fooling around and get on to it. Have you ever walked into your favorite store and discovered that a shirt you wanted to buy is on sale for 30% off? Retail stores often use percents to reduce prices. The dollar amount you save depends on the original price of the item or items that you're going to buy. We see this a lot up the road at the Tanger outlet where they have 30% off, and then what I like to see is the ones that say take an additional 40% off. So it makes it sound like now on 30 and 40 you're getting 70 off, but you're really not. You're taking the 30% off, and then that 40% comes off from what is left. But I have digressed. Don't be suckered into believing you're getting 70% off on those. Let's keep moving here. The shirt you want to buy has an original price of $24.95. It's on sale for 30% off. If you have $20 with you, do you think you're going to have enough money to buy the shirt? Explain your reasoning. This is the kind of problem that you are going to be solving in this lesson. Let's keep going. Can you use a model, how can you use a model to find the percent of a number? Let's find out. There are 300 sixth grade students at Heritage Middle School. 25% of them play a musical instrument. How many sixth grade students play a musical instrument? First option we have is to use the grid to support our reasoning. What percent does each square represent? How many students would there be in one of the squares? 10 by 10 grid, the 10 by 10 grid, explain your answer. Well, first off, each little square represents 1%. We've learned about this, I think, in the last lesson where we had 100 1% things. Now this represents 300 students. There's 100 squares. So how many students does each square represent? Each square represents 3 students. So with that, let us take and I guess we need to bubble in 25%. They didn't really say to, but let's take and go ahead and bubble it in. And when we do, there's my 25% all bubbled in. And of course, how many students are going to be on that? Yeah, we'll answer that. Let's keep moving here. All right, now they want us to actually do it. We're going to shade squares to represent 25% of our kids, so let's do that. All right, I've got my 25% shaded. How many students are represented in the shaded portion? Well, each one of those spots is going to represent 3 students. There's 25 of them shaded, so let's swap over to our scratch work and we will do some math there. We're going to take and say, well, turn my pen on. 3 times the 25 kids in each, or excuse me, 25%, that means there are 75 students that are going to be represented there. So in this spot, I'm going to put in my 75, and therefore you would say that 25% of 300 is 75, and check your answer. The answer checked correctly. Now, how could you use a bar diagram to represent the same information? I'm pretty sure they're going to teach us that coming up. Check our answer over here. That answer checked as well. We're doing good. Move on to resource number 4. At another middle school, there are 500 sixth grade students, and 70% of them play a musical instrument. That's pretty high numbers there. Move through the slides to find the number of students that play a musical instrument. Use 2 bars, one to model the percent and the other to model the number of students. So first off, the percent, we have got 70% that plays the musical instrument. They broke these down into groups, so for the percent, it's going to be 10 groups, so that's going to be 10% in each group. For the number of students, you have 10 groups, so that's going to be 50 students in each group. From here, we're going to take and let's see, let's say the value of each section of the percent bar, we just said, is going to be 10%. Good. And then we're going to say the value of each section of the student bar is going to be 50, which we said was good because you took the 500 divided by 10, that's where the 50 came from. And you can see where those have all been filled in now, just like we've done before. How many sections are in each bar are needed to shade the 70% represented? Well, that's going to be 7, because 7 times 10% is 70. Therefore, you're also going to need to do 7 times the 50. And when you do that, you will get your final answer. 7 times 50 is going to be 350 students. Now, we could take the time to do the grunt work to show that to you, but I don't think that's necessary. It does answer their inquiry question they had a minute ago about how could you use a bar graph or a bar chart to solve this problem, and there you go. You've got one bar that represents percent, one bar that represents students. The bars are the same length. Break it down. Use a 10 by 10 grid and a double bar diagram to model finding the percent of a number. Which do you prefer? Well, we just did that actually. We just used both methods, and I think for me it would depend on how the numbers actually work. Sometimes the double bar diagram is going to work better. Sometimes the 10 by 10 grid is going to work better. Now I want you to pause the recording, type in the answer to this inquiry question, and when you're done, I'll show you what the textbook said was a good answer. Alright, the textbook said, I can use a 10 by 10 grids or bar diagrams to find the percent of a number. Well, they didn't do a very good job answering the question, did they? Because the question was, how can you use a model? They just said, well, they can use a model. So I think they're kind of lacking in their answer there, but hey, that's just me. I don't get paid as much as they do. 50 people were surveyed and asked to vote on their favorite flavor of sherbet. The results are shown in the table. Suppose you want to know the number of people who preferred lemon sherbet. There are several methods that you can use to find the number when you are given the percent. So we've got a total of 50 people. That sounds like some pretty important stuff right there. So let's go ahead and highlight that. It said 50 people were going to be surveyed. So let's highlight that. And we have the statement that we want to know how many people prefer lemon sherbet. That gives us a good foundation of working towards our actual problem. So let's keep moving here. To find the number of people who prefer lemon sherbet, you could use a bar diagram. And we're going to move through these slides to see how that is going to work. Now you have 100%. Each one of these bars are going to be set into 10 equal sections. And you saw in the previous slide that 20% of the people preferred sherbet. So we've highlighted up to 20. And we know that we have 50 people, 10 slides, so there's 5 people in each section. 5 times 10 gives us a 50. So with that, we have what we need to find out the final answer. How many people are going to prefer sherbet? Well, that is going to be 10. 20% of the people preferred sherbet. 20% is highlighted. 50 out of 50 people, 5 sections of people per section, 10 people, final answer. There are some other good ways to do this, and quite frankly, I'm not a huge fan of the bar diagram, as I've said before. The ratio table I do like better. So let's take a look at that. For the ratio table, we had to move from 100% to 20%. So what we did, we knew that 100% of the people was equal to 50 people, so they start off with that. They don't know this information yet. They have a target of 10%. Let me show you this in by hand, really. It'd be better. Alright, I have it set up a little better now for teaching you. We've got 100% of the people is equal to 50 people. But we don't want 100%, we want 20%. So to get to 20%, they divided 100 by 5, because 100 divided by 5 is 20. If you do that on the top, then you have to do that on the bottom. That means we're going to have 50 divided by 5, well, that's going to be 10, and that is where your textbook came up with the answer right here that they're showing you of 10 people. So now we've looked at two different ways to skin the same cat. We've done it with a bar graph, we've done it with a ratio table, and now we're going to do the same exact thing with equivalent ratios. Now, for the equivalent ratios, this should look pretty familiar, but I'm going to break it down for you. The textbook does like to make some pretty good leaps. First off, it gave you some starting problem. You had this information provided, and it's kind of backwards from how they've laid it out before. They've set it up as you got your percents on the right, they got your number of people who prefer the lemon sherbet on the left. So you had 20% liked lemon sherbet out of 100 people, and we want to know, okay, great, how many people is 20% out of 50 people? To do this, what they did is they started by focusing on this aspect of it. They said, what do we have to do to 100? What do we divide 100 by to get it equal to 50? The answer is going to be 2. And if you're going to do 50 by 2, then you also have to do 20 by 2, and that is where the 10 comes from that you see that they just snuck into the answer right there. They did give some supporting work on what they did, and their supporting work's pretty good, but I wanted to make sure you could see step by step how it was actually done. It can be kind of overwhelming to look at it when the whole package is done. And now we're going to look at method number 4 using the double number line. Now all these methods we have already learned. We beat them to death in Module 1, and we're visiting them again in Module 2. For the double number line, what did they do? Well, they set it up to where you had your number of people on the top, and they had your percent on the bottom. Everything was equaled out. It's very similar to using the bar diagram that we use in the first method. So you've got 0 to 50 people and 0 to 100%, and they're broke down into even sections just like the bar diagram was. From there, all you would have to do is find the 20%, look up, boop, there it is, 10 people. I'm not a big fan of this one. It just seems harder to set it up to me. So, what do you feel? Which representation better helps you to visualize a problem? And can you think of a situation in which it might not be advantageous to use that representation? Well, for me, the best one for visualizing it was a bar diagram. But a time when it wouldn't be advantageous is when, let's say, we couldn't divide into the exact even number of people or even percentages. Because on this one, we could get 10% was equal to 5 people. But what if 10% equaled 2.5 people? 2.5 people, that gets messy. Okay. The graph shows the types of snacks that students at York Middle School bring with them to school. Suppose there are 300 students at the school. How many of them bring cheese for snack? Well, we can see that 15% of them bring cheese, and our Think About It says a classmate claims that 15% will be a little over 10%, and 10% is 300. Of 300 is 30, so 15% of 300 will be a little over 30. Do you think that reasoning is correct? It sounds pretty solid to me. Let's keep moving. First identify the part, the whole, and the percent. The part is the unknown. The part is going to be the unknown. For what is the percent we're looking for? Well, the percent is going to be 15%, and the 15%, what is the whole going to be? Well, the whole is going to be the whole group. How many people in the whole group? That's going to be 300. So we know the cheese represents 15%, the whole group of students represents 300, so we got that part right. Let's keep moving. Now, method 1 says that one is to use a rate per 100, and that is actually going to be a vocab term that we're going to have. They don't really define it very well though, so let's take a minute and define that. So we jumped over to our definitions page, and on our definitions page we can see that a rate per 100 is a rate in which the second term or second number is 100. Think about this like the unit rate. The unit rate, the second number was 1 unit. For this one, the second rate or second number is going to be 100 units. So let's keep moving through our steps here. The percent is going to be 15. That means out of every 100 students, 15 of them bring cheese for a snack, right? That one checked. Let's move to the next. We have 300 students, so you could argue that it's 15 plus 15 plus 15, because out of each 100, 15 people bring cheese for snacks, so I'm good with that. Or you could just say, you know what, instead of adding up, let's multiply. 3 times 15, that's going to get us the same answer. Any way you go, you're still going to get the same answer. 45 students would be expected to bring cheese stacks for snack every day. We're going to stop here for part 1 of this lesson. Come back for part 2 shortly.